Are you able to see the board, whiteboard? Are you able to see the board? Hello? Hello? Oh, this is the problem we are getting. So, a hybrid electrical vehicle has a downsized engine. Okay, downsized engine means that the particular rating of the engine is very smaller only. Okay, very smaller only. An electrical motor and ultra for electric propulsion assistance. Okay, it's an engine hybrid electrical vehicle configuration only, but the internal combustion engine is a downsized only. So very small rating power only. Okay, so it is also provided with a ultra capacitor bank. Okay, so as I already told, the purpose of the ultra capacitor, yes, the ultra capacitor bank is to assist. Okay, so whenever regenerative braking is there, that will be storing energy. Whenever a very high energy density is needed, so it will start dissipating, discharging. Okay, so that is a as a result of that, we can able to see that there is assistance from the ultra capacitor bank for the propulsion. So is it assisting, but it cannot able to sustain in that. So once it is discharged, maybe 30 minutes, 40 minutes, it is capable of discharging. After completely discharged, so whenever a next regenerative braking, any braking only, that will energy can be stored in the capacitor. So in between that, there is no any regenerative braking is happening means automatically. So the capacitor, ultra capacitor cannot provide any assistance to the propulsion. So automatically my hybrid electrical vehicle configuration has to go ahead with the existing downsized engine as well as electrical motor only. So this is the basic concept. So everyone could able to understand that. So what's the problem is the vehicle is driven for a 30 minute at constant velocity of 25 meter per second. Okay, so now the vehicle is going with a speed with a constant velocity of 25 meter per second. So you can able to convert it to how much kilometer per hour. So here per second it is capable of going 25 meter with the operating at BSF FC is equal to 270 gallon per kilowatt hour. So what is mean by BSFC? Brake specific fuel consumption. Brake specific fuel consumption. Usually how much watt. Okay, so per kilogram, per gram of fuel, per kilogram or per gram of fuel, how much it can go. So that is another way of mentioning the brake specific fuel consumption is how much gallon of fuel that is capable of producing 1 kilowatt hour. Okay, so 270 gallon per kilowatt hour. So that is the value is given. So and the electric motors. The traction power required for this constant velocity. So what is the velocity? 25 meter per second. So how much is here is it is nothing but 15.2 kilowatt is required. 15.2 kilowatt is required. However, the ultra capacitor bank has an additional 960 kilojoules of energy. So before this problem occurs, so already we have stored energy. So during the regenerative braking, so now my ultra capacitor is charged. Ultra capacitors with a additional charge, additional energy. How much the energy that is now available in ultra capacitor is 960 kilojoules. That is during the captured during the regenerative braking. So now we have to calculate the fuel economy. Now we have to calculate the fuel economy when all the ultra capacitor energy is utilized for the propulsion within 13-minute constant velocity cruising period. So now I am going to engage these ultra capacitors in addition to the electrical motor. Okay, I'm going to engage this. Okay, so automatically what will happen? Already motor is having certain specified rating. In addition to that, I'm going to use this. So automatically, so the amount of fuel, okay, required. So automatically, what will happen here in this hybrid electrical vehicle configuration? We have to understand that the fuel is spent not only to produce the propulsion power. portion of the propulsion power required, okay, by the internal combustion engine, it is also helping. It is also helping. The coupled generator is also helping to charge the battery also. Charge the battery also. Okay. So now, if I'm additionally, in addition to the particular electrical motor, if I'm additionally using this stored energy in ultra capacitor, also means automatically the charging of battery need not to be there. Okay, so that means I need not to have full fuel consumption. Now, what is the required amount of power that is produced by the internal combustion engine? For that alone, I can able to spend the fuel where I cannot need not to spend fuel on producing the charging of the particular one. So, because this is going to be in additionally, it is going to ultra capacitor is going to provide the particular charge for 30 minutes. So, which is facilitating the vehicle to be operated at 25 meter per second. Okay. So now the only thing is I have to calculate the fuel economy. Fuel economy is nothing but how much liter. Say for example, so now earlier it was um, say for example um, per gallon. Per gallon means automatically we can able to say that. So you know that US. So in US and all they will use gallon. Okay. So that means 3.79 liters. 1 gallon is equal to 3.79 liters. So likewise, they still used miles per hour concept only. That is nothing but 1609 meter per mile. So we are saying that 1000 meter is 1 kilometer. We are still using the all using the SI unit. That is 1000 meters equal to 1 kilometer. But there is a earlier we also used the concept called mile. That is nothing but how much meters is 1609 meters per mile. 1 mile is equal to approximately 1.6 kilometer. 1 mile is equal to approximately 1.6 kilometer. Because if you are all engineering students, you should know this conversion, even though we are all said to follow universally. Okay, so universally the same units and etc. standard and etc. Still, some countries are they are not following that. They are using miles. They are using gallons. So how many liters? Okay, they say how many kilometers per gallon. How many kilometers per gallon? Like that, they are able to calculate. Okay, so the readings are available or data are available with that only. So whenever any data is available, we should know these conversion technologies, conversion method also. So we should not use it as it is. So we should not assume that. So what is miles equal to kilometer? No, actually it is one point, or roughly speaking, 1.6 kilometer is equal to 1 mile. In terms of meter, 1609 meters per mile. Okay, likewise, 1 gallon is equal to 3.79 liters. That is also gallon. Also, US and UK is there. We are using US. Here in US, 1 gallon is equal to approximately 3.8 liter. 3.8 liter. Small amount of quantity of fuel less than 4 liter is 1 gallon. Okay, now we have to do the fuel economy. Okay, so what is the first initially is given, data is given is, it's very clearly is given that what is the speed at which it is moving. Okay, so that we have to first write. That is, it is given that speed is equal to 25 meter per second. So I'm using my mouse only. So you try to follow it. Okay, write in the paper also. So this is what the speed for 30 minutes. My vehicle is going to be continuously continuously running at constant speed only. So what is the speed of the vehicle is it is going to run at a 25 meter per second only. Then another one is how much energy that is stored in the capacitor, how much energy that is stored in capacitor. Okay, so the energy stored in a capacitor is equal to, it is 960 kilojoules. Kilojoules. I'm now using my mouse only. So the writing sometimes may not. I'm as far as possible. I'm trying to give with the clarity. 960 kilojoules. Okay. So then for about 30 minutes. So because this vehicle is going to run for 30 minutes. So this 960 kilojoules should be uniformly distributed throughout 30 minutes. So this capacitor, ultra capacitor is going to be additionally contribute to stored energy to the propulsion system. So if it has to do that, how much power supplied? How much power? So now energy stored, we know how much power that can be supplied by the capacitor. That is nothing but how much the kilojoules. So I have to convert the kilojoules into joules. That is nothing but 960 into 1000 joules. How much minutes? 30 minutes. 30 minutes. So I have to find out per second. Okay, so automatically what will happen is 30 minutes. So automatically what I have to multiply? So how much seconds per minute? So automatically it will be nothing but 60 seconds per minute. So automatically what will happen? This minute unit will be cancelled. So joules per second. So how much power is delivered is joules per second is 960 into 1000 divided by 30 into 60. So 30 minutes, half an hour. So I have to convert into power. Okay, power. So here energy. Energy is nothing but how much power into time. That is called energy. So whenever we want to calculate the power, then automatically we have to divide with the time. So the energy is divided with the time means that we can have instantaneous power. So for each second, how much power can be given? So anyone calculated? What is the value using calculator? Hello? Anyone calculator? Nobody having calculator, huh? Then how you are going to appear tomorrow's exam? No one. What's the value? Faculty only has to come with the calculator also. 960. 960,000 divided 30 into 60. That is equal to 533 watts. Joules per second is nothing but equal to watts in terms of electrical. Okay, this is the, so this much of power only is going to be delivered by the capacitor, that is ultra capacitor. So total power required already we know. How much is the total power required? That we very much know that 15.2 kilowatt. Okay. So now there is a one more thing. So now very clearly next we have to calculate how much that is going to be taken from the fuel. Okay. So for that we should know how much is the traction power given. So the traction power is given, that is nothing but traction is given to This is also given that 15.2 kilowatt. So you know that any drive train efficiency cannot be 90 percentage. So that means whatever of the traction power it is produced. Okay, so we know that all the losses and all occurs. It is maximum of 90 percentage only. The efficiency of any drive drive train is equal to 90 percentage only. 90 percentage. Okay, automatically what will happen when I'm using this? Okay, when I'm using this, so I have to calculate how much power has to be developed. Okay, so now power to the wheel is delivered both by ultra capacitor and as well as engine. So now I know I am calculated how much power, maximum power can be delivered for all 30 minutes from the ultra capacitor is 533. Okay, remaining power has to be generated from the engine. Okay, so automatically what is the ultra capacitor? That is ultra capacitor PC divided by engine, that is additional engine, has to produce the total amount of traction power. Traction power divided by the efficiency of the drivetrain. Efficiency of the drivetrain. So automatically 90 percentage only efficiency means automatically when you are divided by 90 percentage, so that additional power also has to be provided by the capacitor and engine combination only. Because if you divided the 15.2, if you divided the 15.2 with the 0.9, automatically what will come? It will be more power. So traction power required on wheels is 15.2 kilowatt, but we know very well the drivetrain efficiency is 90 percentage only. So this combination of both capacitor as well as the engine has to give more power. So now I am interested in knowing this only because I have to calculate. Already I am calculated PC, that is nothing but it can be capable of giving 533 watts. In addition to that, I know what is the traction power required and drivetrain efficiency also. So now the unknown is how much the engine power has to be supplied. Engine how much has to be supplied. Okay, so that is given by. So if I'm bringing this one here, automatically it's minus. Okay, so now so I'm substituting the values. You able to understand. So how much is the traction power? 15.2 in terms of kilowatt. It is kilowatt. Then this is 0.9. 0.9 minus. So since I'm using kilowatt, I'm just converting this also into kilowatt. Automatically, how much it will come? 0.533. So everything in a kilowatt. That's why I convert the given watts to kilowatt. So that is equal to that is that is equal to 16.36 kilowatt. So my engine, so additional power apart from the capacitor, ultra capacitor is needed because capacitor is only giving 0.5 kilowatt. But whereas the efficiency of the drivetrain is 90 percentage only. So take into the consideration of both the efficiency and as well as the capacitor power, the engine has to develop or the remaining power has to be developed is 16.36 kilowatt. It has to be developed by the engine, my engine, P engine. Okay. So now here the question is now we are very clearly we know how much the distribution of the power. Okay, how each is going to take power. This is going to take 0.5 kilowatt. My engine is going to give 16.36 kilowatt because of the efficiency 90 percentage. Remaining 15.2 required 15.2 kilowatt is going to be available for the traction. Now the question is how much is the fuel economy. So for the fuel economy, you should know that how much fuel per hour is utilized. How much fuel per hour is utilized. So automatically this power has to be produced by the fuel only. Okay, that means engine only. So then we can know QF, that is nothing but fuel flow rate. That fuel flow rate in liters per hour. How much liters per hour? Okay, so for that, how much is the power has to be produced? Tractive power divided by the drivetrain efficiency. Divided by the drivetrain efficiency. Drivetrain efficiency multiplied by what is a brake specific fuel consumption. What is a brake specific fuel consumption? So that is given BSFC. I am putting in a short form. It is also mentioned usually in a short form only. That is brake specific fuel consumption divided by the density of the fuel. Density of the fuel. So automatically each fuel is having a different density. So diesel will have one density, petrol will have one density. I think here petroleum engineering students also is there. Can you do you know what is the density of petrol? Petroleum engineering students, can you share the information of density of petrol? Hmm? Petroleum engineering students. Petroleum engineering students, no one is there. Nobody opening mouth. Eh? Whether I am doing problem for myself or to you, I don't know. How we are going to learn. Nobody answering. For calculator also, no one bringing calculators. What is 748.9? Is there any unit? Density should have unit, no? Okay, for your information, I'm telling petrol. If it is a petrol, fuel is petrol means it is having a density of 710 kilogram. 710 kilogram, okay, per meter cube. That means if I'm having a container, okay, with a 1 meter cube, okay, meter cube volume of the container. That means 1 meter depth, breadth, and height. I'm having a container. I'm having a container which is having on all three direction. It is having one meter. So automatically the volume of the particular one is in that I can able to store 710 kilogram of petrol. If the same in the same container, I can able to get I can able to store 850 kilogram of diesel. Kilogram of diesel, so per meter cube. So usually this is what density. So density of the fuel is 710. That means 710 kilogram per meter cube I can able to store. But whereas diesel, it is having a little bit higher density. That means 850 kg per meter cube can be stored. Okay, so this is taken as a uh, fuel density. Okay, so you know from this what is this value? What is this value? Already we know. So we have calculated that is nothing but 16.3x. 16.3x. This is point. Okay, this is point. Multiply by what is the brake specific fuel consumption is given is 270. 270 is given, and we know I am taking for the sake of understanding. I am taking here the fuel is petrol. Okay, automatically how much it is 710. So now I am putting 710. Okay, what is the result? How much liter per hour? How much liter per hour? Anyone say? Can 16.36 into 270 divided 710. It is 6.22 liter per hour. That is equal to what is the fuel flow rate is. So from the tank 6.22 liter per hour. So if I have to produce this much power with the fuel, I am taking this as a petrol. Okay, if I am taking this as a petrol. Okay, so I have to supply the fuel flow rate in such a way that 6.22 liter per hour I have to spend in order to produce this much amount of power. Okay, because that only is going to be produced. Additionally, engine has to produce this much power. So I know what is a brake specific fuel consumption. I know, and divided by the density of the fuel, I can able to know what is a fuel flow. Now coming to the question of fuel economy. Now only we are going to consider the fuel economy. That is, I in short form I am writing. You have to write it in a full way. Fuel economy. So now we are going to calculate the fuel economy. Okay. So now the fuel economy is equal to what is the velocity at which the vehicle moves divided by what is the fuel flow rate. What is the fuel flow rate? But we know that velocity is given in terms of meter per second. But whereas fuel flow rate is given in terms of uh, liter per hour. Here is unit is given as hour, but that is a contradictory thing. So I have to convert in terms of uh, whatever may be the thing. I have to convert in terms of hour. Okay. So in that case, I can able to write. Okay, this is nothing but I know it is 25 meters per second. We know that how much second? 3600 seconds per hour. So that's why I multiply, because in numerator and denominator, the same unit should be there. I cannot have seconds in the numerator, hours in the denominator. So I just convert. Okay, so per hour 3600. So automatically what will happen? Here it will be cancelled. Having 6.22. 6 point, sorry. 6.22 liters per hour. What's the value you are getting? What's the value you are getting? If I calculated and 25 into 3600 equal divided by 6.22, that is 14.46. 14 point, sorry, 14,469. 14,469 meters per liter. This is the fuel economy. This is the fuel economy I'm getting. That, but so you know how to convert from the meters to kilometer. That is nothing but 14.4, 14.5. We can write 14.5 approximately 14.5 kilometer per liter, per liter. This is the fuel economy or the mileage. We can say that it is a mileage. Okay. So in other way also we can able to represent. So as I mentioned earlier, so miles per gallon, how much miles per gallon? So very clearly 14 point, we know that 14 point, this is itself answer, correct? This itself we can close. Sometimes you, as an engineering student, you should know how much miles per gallon, because still European country, US and all, they used to say this only in terms of how much miles per gallon. So I have to convert this fuel economy into miles per gallon. So you know very well how much liter per gallon? 3.79 liter per gallon. How much meter is 1 mile? 1609 meters is 1 mile. So you have to substitute 14,469 into 3.79 liters per gallon. Liters per gallon. Here 14,469 meters per liter. Okay. So then it is divided by, sorry, that is divided by how much meters per mile. So how much meters per mile? 1609 meters per miles. I am putting MI for miles. MI for miles. That is equal to, if you calculated how much it is coming. So I have to do
34.08, sir.
34.08. Wait, I will check it. 14, so 69 multiplied by 3.79 is equal to 54 divided by 1009. So that is equal to 34.08 miles per gallon. So miles per gallon. Okay, so we have to write 34.08 miles per gallon. Okay, so this is how we have to find out the answer. So this is what my final fuel economy. Already we find the fuel economy is nothing but if I'm using ultra capacitor stored energy. Okay, so that I can able to say that 14.5 kilometer per liter. So anyone can say without using ultra capacitor energy, what will be my fuel economy? How to calculate? So that is not asked thing in a problem, but you have to understand. Whenever you solve any problem, okay, you should be able to understand. Then we can able to understand the concept of ultra capacitor. So now, what I have to do? I have to. I should not subtract this one. I should not subtract this one. So the whole amount of power has to be produced by this one only. So what is 15.2 divided by 0.9? 15.2 divided by 0.9. That is 16.88. So the complete 16.88 I have to generate using engine means the same thing we have to use, but wherever we have traction power, here we have to use 16.88. 16.88. So automatically that will have more liters per hour. If more liter per hour means automatically fuel economy also may be 15 point or 16 kilometer per liter. Sorry, it will be reduced. It will be reduced. Okay. So automatically per liter it will be reduced. But whereas here liter consumption, fuel rate will be more. So it may be 7 liters or 7.5 liters per hour may be required. If it is coming in the denominator, automatically what will happen? This will be okay. So automatically it will be changed. Okay. So fuel economy will not be there. So because I am using additionally this 500 watts, the total power required by engine is now reduced. Instead of, so here I can say that without capacitor, okay, without capacitor, I have to produce 16.88 kilowatt, 88 kilowatt for half an hour. This is instantaneous power. This is the instantaneous power. Okay, so what second? So each second. So this much power I have to produce because of the ultra capacitor is there. That ultra capacitor to store the energy from the regenerative braking. I need not to produce this 533 watts. Remaining power only produce for power to be produced, so automatically I only need 6.22 liter per hour only. That means in terms if I am assuming I have taken, okay, I have taken a petrol, okay, 6.22 liter per hour only. So in order to produce the required power, that is nothing but my fuel will give 14.5 kilometer per liter. 14.5 kilometer per liter. Only. Okay, so automatically what level? If additional power has to be produced by this one only means this will be reduced. This will be reduced. Maybe 13 kilometer only will come. Okay, if capacity in the absence of ultra capacitor. So assume that each time whenever I'm braking, okay, whether it decelerates, that means I am decreasing the speed. I am just taking my leg from the accelerator, or whenever I am applying braking. So instead of wasting the energy, that is what happening in the internal combustion engine or conventional in electrical vehicle, that energy can save. That is a very big advantage of hybrid electrical vehicle. So because of that, my improved fuel economy. This fuel economy is improved not because of the performance of internal combustion engine. This improved kilometer per liter is because of stored energy in the ultra capacitor that is used for next half an hour along with the required propulsion power. So this is also continuously discharging. Okay. So in the when the vehicle is it is assumed that continuously maintaining at a 25 meter per. So in between any braking occurs means automatically my capacity will be once again boosted. It can able to store another 5 minutes more. Instead of 30 minutes, I can 5 minutes. So whenever there is a braking or deceleration occurs, automatically the ultra capacitors will capable of storing energy. How it is happening? So what is a propulsion unit electrical motor? Here it will be acting as a generator. So generator. So roughly you should know, always able to remember that a 100 kg weight vehicle, if it is operating at 100 kilometer per hour, whenever it is braking, so by applying a braking, if you want to bring it to back at the speed zero at standstill, you want to make it standstill means, so during that braking I can able to get 0.16 kilowatt hour, that is 160 watt hour energy is there that can be stored in the capacitor. This is a thumb rule like that you can able to remember. So each braking I am just going in 100 kilometer per hour. So I'm applying a braking, I'm stopping vehicle. So in a conventional vehicle there is no any provision for storing energy. So what I mentioned in terms of quantity, that is 160 watts power, that will be wasted only. But whenever we are using either hybrid electrical vehicle configuration or using electrical vehicle configuration, each time I'm braking, I can able to store 0.16 kilowatt hour of energy. That can be utilized. That can be utilized back whenever the vehicle is in a normal operation. By that, the fuel economy of the vehicle is improved. Okay, so that is the important concept. Then this is a one way of understanding another problem. Another way of simple way of a thing is if instead of using a petrol, instead of using a petrol, if I'm using a diesel, I have to, whenever I'm calculating the flow rate, whenever I'm calculating the fuel flow rate, I have to replace the density. So here I used 710 kilogram per meter cube. This is nothing but it's a petrol density. Whereas I have to replace it with a diesel. Okay, so automatically if a denominator is more, okay, as a result of that, result will be coming less. So less liter per hour only will be coming. Okay, so automatically what will happen? Here the fuel economy will be little bit more. So the way we have to understand the problem like this only. Okay, so any any clarification? Any clarification? If there is no any clarification, we can wind up because some of you have to write examination also.